All right. Hey, what's going on, everybody? So now CJ is going to take it away with our intro to Git workshop. This will be super helpful for all you guys who maybe have limited experience with version control and aren't too familiar with how it can help on a project and how useful it can be, especially collaborating between team members. So take it away, CJ.
All right, thank you, Austin. Yeah, so my name's CJ. I'm one of the organizers here at Sunhacks, and yeah, I'm going to talk to you a little bit about Git and version control. So, hello. There we go. All right, so firstly, what is version control? And the big thing to learn here is that version control, when we talk about this, is just a collection of software tools that's going to help you manage the kind of the status or the life cycle of your project as you develop it. It's a good working history of your code, and it gives you a good set of points in time that you can revert to in case anything goes wrong, and gives you that really strong history of how your code's progressed over time. So like the slide mentions, if you make a mistake, it's really, really easy to go back in time and pull a different change. So pretty handy. So there's three main concepts that we're going to talk about here that really encompass Git, and that's commits, branches, and repos. So we're going to go into a little bit more of that right now. But for now, those are the three keywords you're going to be wanting to take away from this. So committing to version control. So when we talk about commits, what we're talking about is basically a timestamp of your current work. So this is the current state of your project. So when you generate a commit, you're summing up your current project, all of your code, rolling it into one package. And we're going to go ahead and send that to our Git repository. We'll talk about that in a second as well. But for now, that is our timestamp of our current state of our project. So to make a commit, there's a couple steps involved, but basically it boils down to we want to make changes to our project or changes to our code. We're going to stage those or add them to a commit. So prepare a package, and then we're going to commit it, seal that package and make it available and sent off to Git. So now, once we have all of our commits, you may want to branch out of a project. And so what we mean by when we talk about a branch is it's just a series of commits, because we talk about the linear timeline of your project. So as you're adding commits, we're going to build this train or this chain of history of your project. And so a branch lets us expand out of that. So for example, if you decide to develop your project down to a certain point and then adopt a new API, you may want to branch off. So you now have two working versions of your code with maybe two different APIs, so you can test them, for example. So by default, we have a main branch, and that's where all of our commits go. And so that is our linear time series. And then we can branch out of that with new branches that we name whatever we want. And finally, we talk about sending our project anywhere. We're talking about a repo. So GitHub, GitLab are all code repositories, or Git repositories, which we also call repos. So in the same way that a branch is a collection of commits going in either direction, as we can see here in this little really cool, cute illustration, our repo is just a collection of all those branches. So it collects everything that you've done and lets you switch around your views. So multiple people can be working in a branch. You can be making changes left, right, and center in that branch or on different branches all at the same time. And it's the repo's job to keep all of that organized. So for example, we can consider the repo the highest level project folder. So if our project is named My Project, our repo would effectively be My Project. And so we can consider we have our code and files in here. So that's what we're talking about. When we talk about a repo, we're really talking about the top level structure of the project. Okay, cool. So for starting a project, we're going to talk about GitHub here, but this really applies to most repositories. But basically, you're going to sign into your GitHub account, and from your dashboard, we can go ahead and hit new repository or new repo. And so you can see here, we're looking at Cecilia's account, and she actually has 29 repositories. When we go ahead and create that, and I'll slow down here a little bit too for anyone that's actually following along with trying to create a repository. But once we hit that create new repository button, there's a couple key things we want to do here. So first of all, we want to set the repository name. This is how we're going to reference our project in the future. We also want to set its visibility. So you can make your repository public, and this is what we see with like open source projects, for example. But we also have the option to make it private. So if you have your own internal developers, you're working with a team or maybe within a company, you'll probably be working with private. Okay, or I'll be working with private repositories. So down here too, we talk about initializing repository. So by default, we're basically just creating a folder here, just like we talked about that top level directory. And so when we talk about initializing repository, we're asking what should we immediately add to that folder before we start working. So usually we want to add a README file. And this is the basically just a description of your project, what it does, what it accomplishes, all that fun stuff. So generally we want to go ahead and select add a README file to begin with. If you're currently working with a license or you want to include a .git ignore, we'll talk a little bit about that in a second as well. Don't worry about it for now. But then go ahead and hit create repository. Cool. So if you would rather do this through a terminal or command line interface, it's even easier, just a couple commands here. But assuming you have Git installed on your system, go ahead and navigate to the folder that you want to actually work from. So CD into whatever that folder is. If you already have files in there, perfect. Otherwise, if we're doing this for the first time, working with an empty folder, we're going to want to go ahead and create a file. So you can either create a file yourself through whatever editor IDE you're using, or you can use the command touch to generate that file for you. And then we want to go ahead and initialize it. So we're going to set up this folder as a Git repository, as a folder. So Git init sets up that initial structure for us. And then next we have this command git add and then a file name. So we can go ahead and put our readme.md, and this references the file that we've just created within this folder. And now we've basically gone ahead and staged our next commit. So we've created that little package that we're going to send off, and we've added the readme file to it. And now when we're ready to commit that and add it to our history of changes, we want to run this git commit command here. And so we want to git commit. This is going to commit the current changes that we've staged. And by adding this -m argument, we can also go ahead and name the commit to make it easier to search, or just when you're looking at your series of changes, you can see why things change, for example, whatever message you've added. And then finally, if this is the first time you're working with this folder, you don't need to do this every time you make changes, but if this is your first time working with this repository in this folder, we want to go ahead and set it up so that our remote repository is in GitHub. Because right now we're only working with our own little folder on our computer. So git remote add origin, and then we can go ahead and include git@github.com, and then we want to include our username / the name that we gave the repo in the previous step, and then just add a little .git here at the end. And this will go ahead and set up the folder to publish its changes up to GitHub so that you can view it from your browser. So once you've done that, we've established that connection, and we can go ahead and push it. So we push our latest staged commit that we've now packaged by git push, and then we tell it where we want to go. So view origin tells us where it's going. Origin is our remote repository, and master or main, now GitHub refers to or defaults to main, but that'll be the name of our branch. So by default, main is your branch, whenever you create a repo. So this tells us to go ahead and push our changes to that existing branch in the remote repository. So now that we've done that, you can actually go to the repo that you created within GitHub, and you'll actually see that readme.md file in there. And now we're going to talk a little bit about cloning, because as you guys are working along in this hackathon with us, if you're going to be using existing open source libraries, for example, or even some of our sponsors selected like code examples that they've given you, code samples, they've probably given you a link to a GitHub repository. So let's say we want to go ahead and clone that to our computer. The way we can do that is when we pull up that repository on the right-hand side here, we can go ahead and hit download, and we have a couple options. We can clone it, we can open it with GitHub Desktop, or we can download it as a zip file. That's totally fine. But let's say we're working on a project here that we want to be able to make changes. The zip is cool in that it'll give you all of the files in there, but it's not going to set up that Git structure for you. So to do that, we're going to go ahead and take this clone link here. So go ahead and copy this link right here. Oops, there we go. And you can use this command git clone, and then you paste the link that you have. So git clone, and then we have this full link. You do this in your terminal, hit enter. It will automatically create a folder named whatever this repo name is, enter the folder for you, dump all the files that it's pulled off GitHub, and set up the Git structure so that you can continue making changes, staging them, and committing them. So now that we've done all that, we know how to start our own repo. We know how to commit or stage commit and push our changes. and we know how to clone a repository to start working with someone else's code, we really want to talk about sharing your code. And to do that, there's two main things. We want to push all of our changes to GitHub, make sure GitHub is totally up to date, and we want to pull the team's changes down. So basically what we're talking about here is because your repo is just a folder effectively on your computer, we need to push our changes to GitHub so that they're in a central location. And then from any other computer, you can pull those changes back down to update your local copy. So if you make changes, you want to go ahead and push them. And if your teammate wants to make sure they have the latest version of the code, they want to pull it. And that'll re-download the code from GitHub, very similar to a clone, and then reset up your little folder so that you have the current working code. So yeah, this is a great comment here, but for the love of God, do not send the zipped up project. So really what we want to do here is make use of these commits that we've learned how to use, and we want to go ahead and push those. So we want to upload that work to the repo. So when you're ready, using those previous steps we talked about, we want to go ahead and add files to the new commit. We want to commit them with that git commit command, and then we want to git push to send that back up to the repo. And now when you want to pull down those changes, or your teammate wants to pull down those changes, you want to go ahead and use git pull as opposed to git push. So pull is a combination of git fetch and git merge. Those are both a little bit more complex. So that's something we can talk about later, or if you have questions about it, I'm happy to talk with you about it. But what we really want to do is in our repository, our own local working directory, or your teammate's working directory, rather than using git push, we want to just run git pull. And that's going to go ahead and pull down all of the current working set of code. So when I say git pull is a combination of fetch and merge, that may sound a little daunting, but basically what's happening is git fetch is just updating our references to make sure that it's currently referencing the correct place in the repository. And then merge, we're going to go into a little bit more right now. Okay, so a little bit of an overview about pushing. We're staging our changes, and then we're saving them, and then we're sending them. Or staging, committing, and pushing. So we want to add all of our files. You can do git add and then a file name or a folder name, and that'll go ahead and stage those files or folders. Or if you want to go ahead and just add everything in the current folder, you can use git add dot or git add period. And that will go ahead and just take all of the files and folders in your current working directory and stage them. And then we want to go ahead and save them. So we can do git commit -m and then the message about the code we're changing, or our commit message, or we can just run git commit. But this is going to open Vim or whatever your default text editor is from within your terminal. And it's going to ask you to write a commit message here. Definitely easier to just use the -m. Then finally, when you're all set and done, git push will go ahead and send all of that code up to your remote repository, GitHub in this case. So push flow, git add files, git commit -m, commit message, git push origin branch name. So git push origin main, or if you're working in a new branch, whatever that branch name is. Cool. So here's kind of a full rundown. If we were to go ahead and clone a repository, for example. So we paste in our git clone and then a link to the repository. It's going to clone it, create that folder. We can go and enter into it, and then we'll see our file in here, whatever files were in that repository. This is a super handy command, git status. This allows you to see whether or not your current working directory is up to date with the repository. This will actually check to make sure your teammates haven't made changes that you should be aware about. And it'll tell you if there's any current changes. So for example, we know that this branch is up to date and that README has been modified because we just downloaded it. So that's useful to know. So we go ahead and make our changes, do whatever we need to do. And then we can go ahead and add, stage that file. So git add README. And then we're going to go ahead and commit it. So add our commit message. So we'll see that it says that it went ahead and created a new commit, gave it a name, tells us what changed here. So we have one file was changed, 3 insertions and 1 deletions, means 3 lines were added to the file while 1 was deleted. That's all that's saying there. And then finally, git push is going to go ahead and upload that code. So it'll tell you what it's doing down here, but it's just uploading it to GitHub for you. All right, merges and conflicts. This is where it gets a little bit fun. So merging is exactly what it sounds like. When you push or pull to your repo, differences in the code get merged, which normally is not a big deal. super cool. Your current code and the latest version of the code, merge them together, you have the latest. But things can go sideways. So occasionally you might run into a merge conflict, and it just means that you're currently pushing code that's newer, or sorry, you're pushing code that's older than what's in the repository. So you forgot to pull your changes before you pushed them, for example. You did not realize your teammate already uploaded code. So it can also work in the opposite direction. You could be pulling code that overwrites your own code because you forgot to commit your changes. So for the most part, Git will try to handle it automatically for you because it can figure out the differences. But if not, it'll tell you that there's a merge conflict and it'll stop so it doesn't accidentally mess up your project. So when that happens, how do we handle it? So first, we want to manually choose which code goes through. So in our text editor, we can actually decide what code we really want to commit, send, or pull. We want to make sure that we know what we're actually working with here. And then we want to go ahead and stash our changes, or we can reset the branch. So you can either git stash, or you can do git reset head. Specifically head like this, and that tells it at the very top of the tree. So all of your commits, all your branches. So git reset, this is a powerful command, but it's going to reset all of the files in the previous commit, to the previous commit. So whatever you have, it's going to overwrite and bring it back down from the latest. So you also have to decide if you want the current change or incoming or both. So head means the current change, or tail means the incoming change. So you can reset head or you can reset tail. Or you can download the Git GUI, and it has a merge conflict helper. It makes it even easier, which is what you see in this little screenshot here on the left. So that's that. Okay, cool. So there's a couple tools here that make your life easier when working with Git. So we see Git Bash, Git Kraken, Git GUI, Tortoise Git, Smart Git, Source Tree. There's all kinds. But the easiest one to get started with right off the bat is GitHub's own GUI. And you can download it from GitHub's website or from your repository when you have that download option. Cool. All right. So if you're interested in learning more about Git and going into more of the technical details and just kind of getting into it a little bit heavier than what I've covered here, here's a couple of really good resources I'd recommend. GitHowto.com, really cool place to learn more about this. And then git-scm.com. This is more advanced stuff, but this is the deep dive Git knowledge. So that's a good way to get that. And then naturally, you can also search Google for how do I do a Git, blah, 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 or copy and pasting your Git error, as I'm sure we're all used to. Oh, here's a good note. Read the Stack Overflow answer in its entirety and backcheck so you don't accidentally overwrite your whole master or something. Git is a very powerful tool. Git is very powerful. And if you're not careful, it does, like, for example, in the merge conflict scenario, you could end up resetting code that you may not want to reset. So don't just copy and paste answers from Stack Overflow. Make sure you understand what's going to happen to your code when you run that command. All right. Last but not least, have fun and ask for help. We have a bunch of mentors at our event this weekend. So if you have questions about Git or any other technology in general, ask someone. Post it anywhere in the Discord. We have a really nice mentoring channel. It's a good place to ask questions. And if you really want some one-on-one with the mentor, we have mentoring tickets, and you can open a ticket with a mentor. Also, if you have any questions, I'll stay on for a little bit, and you can ask me some questions here. But yeah, that is all I got. Austin, do we have any questions? I think he's currently running back to the computer. Go.
I didn't see any questions, CJ.
Fantastic. Okay, cool. No worries then. All right. Well, we're actually just about on time anyway, so I'll go ahead and yield my 3 minutes. Thank you all for joining my little presentation, and I hope you learned something new about Git today.
Awesome. Thanks so much, CJ.
Thanks.